All right. Well, thanks, everyone. And thank you, Wolfgang. We're running a little behind, so I'm going to try to be quick about my introduction for Paul Kephart. I want to thank him for being here tonight. Paul is the president of Rana Creek Habitat Restoration, and that's based in Carmel, California. Those of us on the Ecoroof team have been really dying to have an iconic green roof project in Portland. We'd love to have something that Portland can say, it really says it's a Portland green roof. And fortunately for us, we have an expert in the ecological design field here that's worked on some very iconic green roof projects. And so we're excited now that we've heard about the policies and the trends in that part of it. We're really happy to have Paul Kephart here to talk to us a bit more about his experience with the ecological design aspect of it. And so without further ado, please welcome Paul Kephart.
Well, thank you very much. I'm very happy to be here and honored to speak with you this afternoon. I'm inspired by your commitment and dedication and all the hard work here in the city. And truly, we have reached that era or time of change and tipping point, and at no time in our history on the planet have we ever had such impacts, and have we ever had such opportunity to correct those actions. And today I want to talk not just necessarily about the living roofs or green roofs or vegetated roofs, or as Tom coined the phrase, the Ecoroof, but I want to talk about large-scale applications of living architecture where we're looking not at green roofs or living walls or passive ventilation or natural daylighting or these green measures as segments or objects or individual applications, but rather how through an integrative design process we can combine the organic, natural, vegetative living systems, functions, and processes as part of that mechanical building, plumbing, and energy system. So that'll be the focus. I also want to somewhat describe the evolution of this design, this ecological design practice from my perspective in doing this for some 25 years now. And it is an integration of art and science and sustainability with that true emphasis on the philosophical connection we have and that spiritual connection we have to nature. And I'm thinking about where that green staircase will lead. I had my start as an artist and ecologist in Big Sur, where Mickey Munich came to me and said, and he had one of the first low-impact development projects on the coast where he said, we're not going to build roads, we're going to respect the local hydrology and that mantle of soil and earth, and built his bungalows and hotel units in the redwoods without cutting down a tree, and lifted them up off the ground plane. And then on the coastal bluff, I was studying the coastal terrace prairie, some 250 species of vascular plants. And I was concerned, and I said, Mickey, you know, I'm worried about this. I've been studying the diversity and the rarity of coastal prairies. And Mickey looked at me and said, well, why don't we just lift that up and put it on top of the roof, and it'll be as a part of the site. And we did that, and that was 25 years ago. And then sometime later, Bill McDonough came to me and said, Paul, I have a project, and I consider this a courageous project. Of course, at that time, the North American movement in terms of greening rooftops hadn't even caught on, and we didn't have those kind of metrics, and we didn't have a whole lot of information. Most of these rooftops were in the form of on-podium or plaza applications, and they hadn't fared too well, namely the Kaiser Center or the Union Station, both of which failed. And Bill said, I want to develop a landscape, or I want to bring that ground plane up on top of the roof. And I was doing restoration ecology on San Bruno Mountain and thinking about those McCargian type environmental factors of slope and aspect and orientation and wind speed and solar gain, and thinking about how that affects soils and other geophysical applications of the science of restoration ecology. And I wanted to model or mimic or simulate the composition and diversity and density of plant community structure. So I was thinking about restoration ecology on rooftops, and Bill's rooftops with those beautiful undulating swales gave me an opportunity to look at south-facing species and ephemeral annuals on the south slopes, and those cooler sides and swales with wet-loving and cool species. And that was how we modeled this rooftop. And we also developed this idea of a bioswale some 3 stories above the ground plane. Now this is what's interesting. We developed that bioswale with Juncus patens and Carex texensis and other wet-loving plants, and it would clean and polish and filter that toxic, poisonous, chemically volatile material out of the air, and purify and cleanse and adsorb water and moisture. And then we took that water and we took it right to the stormwater leader and right out to the storm drain. Well, we'd never considered doing that today. And so in my discussion today, I want to share with you some of the ideas and the importance now that water has in terms of this integrative design process. And another theme that Mickey had mentored me about was site integration, this idea of respecting the natural contours and the hydrological features of a site and match lining the structure or the site or the roads or the conveyances to that natural topography. And I said, Mickey, I'm working on this criteria for architects in which I can help them understand ecological design principles of site applications for site integration, site and structure. And I said, how do you do it? And he had that twinkle in his eye and he said, intuition. So it's not only about, thinking here with our minds, but also thinking here with our hearts that we can achieve some of the greatest results. And this little project that we had done for a house in the Santa Lucias, 190 days, 175, 190 days without rainfall, extreme temperature variation there in the Carmel Valley and the Carmel Highlands. And we integrated this with passive ventilation, and that at the base of that house is a constructed wetland with gray water. And there are vents that are hooked to a heat chimney on the hot side of the house. And that pulls that cool air over the surface of the gray water wetland through the plenums in the floor plates and exhausts that air out the top. And then the rooftop is insulating, and they elected not to use any air conditioning here in this house. So it's been very successful from an energy conservation standpoint. And then we also selected and collected all the species for this project from the site. And then this project, it really started my continuous debate and conflict and tussle with landscape architecture about amenity and adornment, that continual struggle between form and function. And I worked with Pete Walker, and Pete and I still have a spirited dialogue in regard to the application of landscape architecture and the ecological processes inherent. And Pete said, Paul, I've got this parking structure outside of the Stanford Medical Center, and I want you to develop a plant that is 10 inches high, is evergreen, never needs to be maintained, you don't have to water it, and it looks visually like one solid continuous panel. I said, well, why don't you use AstroTurf? Well, this began that, my understanding of this Harvard School of Design, in which we're looking at the site from an artistic standpoint, this texture and color and panel and the idea of palettes. Well, my paints are I paint with a palette and I assemble plants in cooperative assemblages. And knowing that in ecological practice that where our systems have greater diversity, they have more stability. They're resilient to invasion by parasitic organisms and also to climatic fluctuations and change. So I went along with Pete's idea, and I put that green haze out there on the landscape. And I also said, Pete, wouldn't it be interesting just to experiment and put a few little sprinkles of wildflowers for the patients that look down on this rooftop? And he said, okay. So I kind of affectionately call this the eco-hijack because I actually used 26 species of plants and about 60 pounds of seed and planted it with a suite of plants that were early and late pollinating plants for rare species of butterflies and insects. And I just visited this site, and the other concept we got through here was this idea of decadence, dormancy, senescence, and decay. Oh my! You would think that, you know, this these ideas in sustainability that, oh, we have brown roofs where they're dying. Well, that part of nature is also important. It's during that decomposing state where we have the highest level of ecological function. We've got all that composting material going back and replenishing the biota in the soil and cooling those rooftops during the hot time of year. But we actually got the town of Palo Alto to accept some brown grass. And this has always fascinated me in that, you know, we have this Eurocentric idea of landscape, in which case if I'm in Connecticut or Maryland or back east and it's Halloween and the leaves fall off the trees and the grass turns brown, that's okay. But here in the West, and particularly in the arid West where water is so precious, that's not okay. So it's also this shift, this paradigm shift that we were able to achieve. And I just visited this roof. It's 8 years old, and it's just functioning magnificently. They just mow it once per year and irrigate it a little bit during that season to green it back up. And I looked across the way, and here it was such a wonderful picture for me, is that there, right across the way was this sward of turf with 4 people with mowers and all this noise pollution and all the things that are associated with that big expanse of turf. And it was a great comparison on where we can go in the future with these landscapes. And then this little project is really a fascinating project to me in that as a land use planner, I call that the dark side. I was able to convince the having done ecological restoration as part of a reconciliatory mitigation process, the U.S. Fish and Wildlife Service to use the rooftop as part of the mitigation for the site. Never been done. You know, typically when we mitigate off-site, or we find intact habitat, or we find set aside, or we actually do ecological restoration to enhance habitat for, in this case, the Smith's blue butterfly, which is dependent in its larval state on the Eriogonum parvifolium, the cliff buckwheat. And so we planted cliff buckwheat on the roof, and now you might think that my life as an ecologist is easy, but I have to sit in that hot tub with field glasses and monitor for those butterflies. And they get larger in scale, and I'm just so, I can't wait to get up every morning because of the industry and where it's going and the kinds of projects we're seeing. The Vancouver Convention Center, I remember walking into the room, there were about 30 people, and there was the model, and I just said, this project is all about water. And truly, we developed a wonderful project here with L&M and PWL Partners, landscape architects, and that we planted some 29 species of grassland ecology and forbs and pollinating species, and allowed for seasonality and high levels of diversity. And those key lines were engineered by slope and aspect and roof orientation to look at the runoff coefficients in those particular segments, and they are sized only to handle that amount of water as the folds went down the roof. And interestingly enough, function informed form, and the landscape architects took that idea and they seeded part of those angles and they planted other parts, and it's created visually a very interesting functioning landscape. And I was just there, and it's really a pleasure to go back and see these projects. And I went on a tour and I looked in the basement, and part of our big idea was integration of water. And stormwater we lost early on with the sustainable ideas, but wastewater we hung on to. And there are biodigesters in the basement of the convention center, and the day I was there were 11,000 visitors watering the roof, and all the wastewater from the digesters is filtered out of the waste, and the digesters digest the solids, and that goes into a processing and storage of two 20,000-gallon tanks, and that irrigates the roof throughout the entire summer month. And it keeps it lush and green and vibrant and flowering. There's bees up there. But it also is reused to reflush toilets. Well, I learned something there that made me happy and successful. All of the energy they're saving through transvaporation and cooling on the rooftop has now paid for the entire Blackwater system and its operations, maintenance, and upkeep. So it's time to celebrate, because we're taking these integrated sustainable measures and we're getting an ROI. We're actually getting some return on our investment, and that's when the incentive is there. So a great project, good people. And then this little project is really about branding, and we're seeing more of this corporate branding in that Williams-Sonoma had their little West Elm store, and this project is right near the Maze in Emeryville, just near Berkeley, off the bridge. 240,000 people drive by it a day. So great exposure, lost in a sea of concrete and big box stores, and also it's about closed loop. So all the entrained water, that on the roof, goes into that flow-through planter into a submerged Xerces tank, and then that water is recycled, both irrigation water and storm water. Anything that overflows goes into a bioswale infiltration basin. It's zero runoff, and we cut potable water by 50% for the lead. And it's about this little coastal prairie, and somebody said, well, Paul, what good are these biologically diverse rooftops in a sea of 500 square miles of concrete, steel, and glass? And I said, well, they're only as good as what they're connected to. And if there's a churchyard or a schoolyard or a right-of-way or another rooftop, we're starting to get this idea of habitat connectivity throughout a corridor. And I'll illustrate that later, but we're attracting certain butterflies to this rooftop. no runoff. And we'll take all that water and use it and train it on the roof, have these patios that are terraced, so it's all gravity, and put our PVs up there as well, and then down into a bioswale and tank and back up. So another closed loop example, and now the people that live here are using this for food production and herbs and recreation. And this project is in the Nueva School. It's a great example of site integration on that ridge, and the students are involved in a web-based scientific monitoring project where they're looking at energy efficiency and water quality and water runoff. There are two roofs there. I was just up there. One of them has an abundance of coastal chaparral. There's a picture of us standing on the rooftop on a slope with vegetation to our knees. And it was absolutely so aromatic. I don't know if you've used this little plant, the Stachys bulata or Stachys aegigoides. It's a late blooming plant, so it's really wonderful for hummingbirds. And I was absolutely shocked at the abundance of flying creatures on that rooftop. Moreover, I was just surprised and elated with how well it smelled up there. And the kinds of research that's being conducted, that dashed line, that 60-degree spike on that one day is an external air temperature, and the other lines are the variation on the vegetated roofs. And then a local project that this is just taken 2 days ago on the Drew School, and that's our crew installing this. And this is an interesting project and somewhat of another one of those tussles that we get into, and that has a Patrick Blanc wall. And I had said, well, why don't we take the parapets and the rooftop and we'll just blow out the parapet and not have any area drains on the roof, and like Scarpa would, we'll run all the water right off the roof and over the wall and into a stormwater flow-through planter wetland system at the base of Patrick's wall, into a tank in the sidewalk, and then closed loop prior to overflowing to the storm drain. Now, these walls that Patrick makes they're beautiful, but they also are hydroponic, and that's an example of the rooftop. But I wanted to show you also, and I'll get into this story a little more, we're encouraging greater levels of organic material in our soils, and also this was one of the first little specifications that we actually put earthworms up on top of the roof. But Patrick's walls are absolutely gorgeous. He's a horticultural genius and a wonderful artist. However, these are hydroponic systems. They're based on felt. They're stapled up to a hardy board, drip tube with a fertigator with nitrates and phosphates. And I said to the client, let's think out of the box. Let's take the water off the roof, blow out the parapets, and then take it and collect it. And we got a grant to do that, and so that we aren't taking this some 4,000 gallons of water a day full of nitrates and phosphates and dumping it into our storm drains. Great. PUC loved it, gave us a grant. I found out after I had signed my contracts to build this that they VE'd out all the recirculation and the storm water. So it was really a big disappointment. And then I'm thinking, well, the only thing green about this project is Patrick's hair. And I'm getting a little testy, which I sometimes do. I'm starting to, beat my chest, and I haven't gotten through it yet, but that's a picture of it. I think the message here is that these aren't suitable for arid Mediterranean climates unless we're going to reclaim the water. Now, out of that 4,000 gallons, that's 10, and this is just one half of the wall that's just been planted, 100 species of native plants to the Bay Area. So high level of diversity, very creative, very visionary, but I'm not so sure how sustainable, and I'm kind of concerned about the sustainability. And I want to get that word out there. Unless these have a recirculation system or some kind of capture and reuse, I wouldn't recommend them. And I'm a little concerned about the viability long term. Here's the growth just after a couple of weeks. And of course, what I call this is a rug on a drug. And so it's hydroponic and nitrates and phosphates. And when you start to add it up, these are some of the projects that Rana Creek has been involved with around our Bay Area. We're really starting to get the pattern and connection. I know this pales in comparison to the density that I saw on your map this morning of Portland. Congratulations. But these are just Rana Creek's projects, but I've started to add it up and keep score, and I thought, well, how much rainwater are we actually starting to retain during those storm events, and just our projects is 28 million gallons a year. And the San Francisco's South Van Ness project on an old bank building, this is a retrofit, recycled all the insulation and all the old pavers and every bit of the ballast gravel. And we created a habitat there for painted ladies. We took the air conditioning ducts, which are as long as this room and about 6 to 8 feet tall, and do this. We painted the mother painted lady on that structure and then planted the whole surface for painted ladies, and it's a field of dreams. They came. It's a beautiful thing. But this was our first example of where that penthouse, we captured all the rainwater and stored it on the roof, and then we're gravity feeding that water to irrigate the roof. So a lot of good things happening, and the California Academy of Sciences is another example of, when everything fits. 2.5 acre living roof, LEED platinum structure, just a brilliant design team. And one of the first things we did, and I've often recommended, we did this at the Vancouver and we did it on the Gap, as we build these mock-ups, because oftentimes people ask me to do things that haven't been done before. In this case, they asked me to retain 6 inches soil on a curvilinear slip plane that's 70 degrees. And I said, yeah, of course I'll do that. And, and I remember the design team, they got me over at a restaurant and gave me a couple glasses of wine and then started to interview me about whether or not I thought we had the stability of this rooftop figured out. And I was doodling and sketching, and I looked up and I was, we wouldn't have any problems. No, we got this figured out, and this is how we're going to do it. And I look up and they're video recording me. So sometimes you got to have somebody with the target on his back. But when this started to get real, if you follow the trajectory of that slope, the top of the dome is somewhere up here above the projector screen. That's giving you the idea of scale and mass. And about this time, I started to lay awake at night wondering what I got into. But also you think about how these loads telegraph and through the structure, and we put all our drainage systems in a grid pattern over top those beams. And I remember, here's this other tussle story between the form and the function. I had developed this beautiful lacy key line design on top of the roof, minimalist, just what we needed. And Renzo's team came back with this grid over and atop the domes. And it was because it would mimic the look of the streets of San Francisco as they go over the, and I thought, well, how ridiculous. But as it turned out, that was a really good idea because it gave us an opportunity to randomly stratify the whole roof in 97 cells. And now we have edge effect controlled, and we can do experiments. And really, actually, as Renzo said, Paul, we're just going to provide a canvas that the Academy can paint on. And this is just part of that, and that we began to learn other things when LEED would come into play, and that Renzo's team and their sense of aesthetic, they like this polished rock that's picked up by Mexican children in Baja off the beach. And so I said, well, why don't we use this old cobbled up mine waste stuff that's just 100 miles north. And it was a good process because LEED kept us honest and we actually made the right choice. And then I was trying to figure out how to retain soil around those skylights, and came up with these gabions and channels, in which case you can imagine over a 5-year period you're losing infiltration, and during big rain events, that sheet flow, you want it to get down to your drain layer and off the roof. Erosion happening, from the bottom of a slope and cutting up. And I remember Renzo saying, well, Paul, you tell an interesting story, but it has to be beautiful. And I didn't like this very well, so I then came up with what I called the Victoria's Secret solution, the underwire bra. And that retained all the soil there without having those big clunky gabions in the channels. So We then planted this with our 4 species of perennials and some 6 species of annuals, targeting pollinating periods throughout the year and biodiversity, and began to hone in on PLS seeding rates, pure live seed, and in order to get the right composition. But you know, when we started to implement, we also did another mock-up there in the lower corner, but you can start to see the complexity and the scale and the size of the transitions. And here's another way in which we retain that soil is there's 2 layers of insulation, and the top layer is simply separated, and that gabion basket is sitting on the bottom layer, and there's a lock channel, and then rebar through that and tied by these fabric or fiberglass poly straps and anchored to the other side of the dome. So essentially the weight is cantilevered. If one of those cells were to move, then it would have to drag the weight of the other side over the top. And that was the part of the solution. And then we began to divide those cells into smaller segments, but I think now you can get an appreciation of the slope and aspect and orientation, and sometimes it rains, you know, 6 to 8 inches overnight or in a 2-day storm event. We haven't had any erosion or problems, and it's fully vegetated. And this was a great effort by Jensen Landscape and how we tiled up these trays. And the bio tray was also an interesting part of the story, in that Renzo challenged me and he said, "Paul, I want you to come up with a method of getting the plants up there that doesn't require what we typically use in our landscape or nursery industry, or plastic pots." And I had used coconut fiber in pots before, and I developed this tray that has 36 bacillum of mycorrhizal fungi that fix phosphorus in the soil and enable plant growth, and a natural latex rubber, and called it the bio tray. And it was really a successful method of getting soil and plants pre-grown on top of the roof at an economical way, and it was it turned out really nice in that the trays did what they were supposed to do. They biodegraded and left behind some carbon and organic matter, but now it's seamless and you don't see them anymore, and the flowers have emerged, and that's just the way in which we planted. But the whole roof evolved, and now we've applied that technology elsewhere. And so where from here? Those are built examples, but now bringing you fast forward into the future to large-scale design opportunities where we're pushing that envelope and bubble on integrated water management and design as part of the structure. And we're reaching for these objectives, in that we're not going to use potable water for irrigation. And that's particularly important in the Bay Area, where we have some estimates of 60% increase in water costs over the next 5 years. And we're not going to use potable water for non-potable applications. Why are we taking drinking water and using it to flush our toilets? I'll never know, especially in the deserts. And no groundwater and stormwater discharge. I think we're there. We're getting there through regulation, the Clean Water Act, and we're getting there through LEED with site credits. Treat waste and water and stormwater as part of an integrated system and as part of structure. That's like science fiction. You know, few projects we're getting there, and architects and clients look at us like we're sometimes loonies, but that's okay. We are. And encourage biodiversity. And finally, this most important topic: never tell a developer together you'll save the world. Tell him you'll increase his bottom line and save the world, and we're getting there. We've got now a gray water calculator. We just did a project for Ford on reuse, 250 homes, 45 of those homes providing all the water for all the irrigation they can possibly use in landscapes, and it pays for itself in 3 years. So that's where we got to get to, and when we start stacking those applications together, what the permaculturists called stacking functions, or this idea of multi-functionality, I want to highlight some of those things in these 4 projects today and give you an indication of the trends and issues, resilience and integrated project delivery in water, choosing by advantage. This is a $1.7 billion hospital built at the location of the Jack Tar Hotel in Geary and Franklin, really urban place. This was where Steven Spielberg wrote one of his first screenplays called The Conversation, for all of you trivia buffs out there. But we also went through this integrated project delivery, and we developed 7 rooftop gardens that are fed by gravity and that end up in a collection basin or a tank below the structure. And we then began to think about this big gap we have. We have all this demand in the summer for water, and then we have 0 storm water. So we need to fill that gap with waste streams. And I said, how much water is the cooling tower blowing off? And it was 12 million gallons. So great, give it all to me. I'll take it all. We'll commingle it with our storm water, and we'll use that all throughout the summer. And it just got us to about 50% potable water usage that we could decrease. And then we increased our real estate and tank size, and we got to 100%. But that's kind of the idea there for the hospital, and that looking down on this side of the structure, there's the connection, and some 5,000 visitor patients will have access to either visually or physically to these rooftops. And these are modeled after ephemeral ecologies, and I first saw this done on cobble substrate in Switzerland and applied this to our western landscape ecologies and actually changed the composition and the basins with higher levels of particulates and finer particulates and clay, dolomite, so that we can actually retain water and spill that water and get that, mound, intermound, basin effect of shrinking and growing water bodies, so that we can encourage these kind of species. The butterflies require that kind of a mud surface for triggering reproduction in the springtime. And the water story is interesting in that we've, by advantage, chosen this additional water catchment with all of the storm water and all of the cooling tower water. It's going to save about 1.2 million gallons a year. And it's really about resiliency, about a 3 to 5 day water security for the hospital, thinking that the Bay Area, San Francisco's water supply is 187 miles in a single pipe to the Hetch Hetchy Reservoir in earthquake country. That's the other thing. We always talk about the warm, fuzzy stuff, but we really need to take the gloves off and think about survivability in our cities in times of catastrophic event, and I think we're beginning to see the acceleration of those events globally. And here's another interesting project that is a bigger scale, just to kind of tweak your imagination. 9 acres on deck, and this is for the Croton water treatment plant. Delivers 50% of the drinking water of Manhattan, and it's submerged 3.5 stories deep. And when they had excavated, they found 4 artesian wells that are producing about 50 gallons a minute, and it has chromium in the water, which is a hazard. And so we decided to take that back up in this crescent-shaped constructed wetland, and all the entrained water that's going through the golf course and the driving range goes back into the wetland. All the storm water goes into the wetland, and all this pumped water out of the subfloor goes back into the wetland. And while these concepts at this elevation appear simplistic, the brain damage we went through over spreadsheets on residency time and calculating the square area and the variance in flow and source models to come up with the size and the type and typology of the wetlands was challenging. And zero runoff, so all of this water then is entrained and reused. Now you'd think that would be a challenge, but the biggest challenge when I talked to the golf course, now remember, the homeland security issue, people flying over this are going to see not the water supply of New York City, but they're going to see just a driving range and a golf course that's seamlessly integrated into the golf course of Van Cortlandt Park. And then any of the public that are in the park and doing their golf and recreating, or they can't get onto the roof to the plenums because of this moat. But that's the big idea there, and again, that biggest challenge was I got the list of the cultural practices from the golf club, and they had 26 different types of chemical, inorganic herbicides and pesticides that they use as a part of the management of the golf course. Well, time to push the red button. You know, we've got all this purified, clarified stormwater and treated groundwater, and now in training that and moving it through the system. So the good news is we've developed organic standards and have created a waste and nutrient monitoring system so that we can manage the nutrients that go through the wetlands. And it's funny the kind of things that occur in the design process. And this project I absolutely am I'm thrilled with. And I could talk about projects from now until midnight because it's so fun to be engaged with great architects. And this was really about holistic design. We had no barriers in terms of water. And so we took storm water off the roof and gravity fed that into the atrium. This is being built now. All these projects are being built. And again, we're thinking about, there's a car culture, Monterrey, Mexico, Diacero headquarters. Everybody has their own car. Everybody drives their own car. 5,000 cars come to work. So they developed this big parking structure below grade, and I said, well, why don't we put the constructed wetlands to where we can use passive ventilation coming off the rooftop through the atrium, which is, you know, a big hot sink, and then over top this constructed cool air and put these chimneys on the south side, hot side of the building, and then embed those into gabion channels that are pervious all the way down into the parking structure and pull that cool water over the constructed wetlands. Now these constructed wetlands are also the entryway to the atrium, so when you arrive you'll go through living walls and waterfalls and flow through planters. But with the combination of the black water treatment, the gray water treatment, and the storm water, we were able to do some really cool things. We have 740,000 gallons of water a month that we can't even use. That's being exported off the site and given to the city to grow park trees along the causeway because they have no water. And it saved us about 1 million gallons. And I know these are small numbers, but they're important numbers. And it saved about $20,000 a year. And it pays for itself in 3 to 4. So again, we're starting to get there. And I'll talk about one more project in design that is really fascinating, a 6.5 acre park downtown San Francisco. And this is really about policy shift and change in that the first design charrette, that's me in the background not paying attention, we were thinking about the big ideas for the project, and that tower was in the scheme at the time, and I was thinking, well, what's the capacity of the park to, as a metabolic organism that cleans and physically, mechanically, and biologically processes water and waste? And it must have been 3 in the morning on top of the hood of a car in San Francisco that I was sketching some of these ideas out for the design competition the next morning, and talk about deadlines. And so we came up with this idea of constructed wetland, and I'm thinking, you know, just raw ecology, willows and cornice and lameness and decadence and birds and, just wildland. And of course, things changed, but we're still reaching our goals. And then I drew this little cartoon about the water processing, thinking that we could take that water and process it through the living walls. And it's interesting how this is what Renzo taught me about these little abstractions and cartoons. They're so informative that we could take water and bring it through the living walls and bring air with that water and kind of bubble it up through the constructed wetlands. Well, we're getting there. The design ideas are linking water to energy, and we're also looking at the off-site impacts, and so now we're bringing stormwater from all around the building. LEED looks at the site and at the structure internally. We kind of said, okay, well, what's out of the box? So can we take water, stormwater and wastewater for other locations and treat it? And then it's also important for habitat, and that's been our designs. And working with Pete, he's come up with a somewhat complex scheme with a lot of program, and I'm glad that he's there because he really fought the good fight with keeping this park a park. You can imagine the municipalities saying, well, if I open a coffee shop, we'll have revenue. And, oh, I want a basketball court and yoga pavilion and amphitheater and 6.5 acres later, we've got a strip of lawn and maybe a couple of flowers. That's not the case. We really achieved great things in that first time in North America, we put this large-scale gray water processing on top of the structure. So all of this water is featured and it's flushing the toilets and it's gray water cells. The water's entrained and it's subsurface, which meets our code. It was a real challenge with code, and this is the vision, big basket columns and 6 feet of growing media. So mature, I can envision that, that's Pete's vision on the green side and Rana Creek's vision on the brown side. But notice the importance we put on certain occupants, not the crack dealer, but the importance on certain species is a part of the vision, and that's the constructed wetland for gray water. And I can see we're going to have, canopy forest because, 6 feet of growing media, but that's between 2 decks, and there's a lateral cell that are quite extensive for lateral root growth and development. And we've modeled the life cycle weight of this, and those basket columns are going to hold it up. And these are the species right downtown. I was seen lately running downtown San Francisco chasing 2 dragonflies to see where they went. And sure enough, they went right down the storm grate and found a little breeding ground. And then the scorecard looks like this. Our water savings is equal to, about 9.5 million gallons, or what is that, 115 residential homes. And then the numbers are starting to look pretty good, but on a structure like this, it's pretty tough. Policy achievements, we actually got a variance with the PUC, the building department, and the State Water Resources Board on the gray water. And that was not necessarily the only part of the green features. So this is an aggressive, ambitious project with natural daylighting and semi-conditioned space, and really a great opportunity to be a part of this. So I got a few more things to talk about. Would you like me to continue? Yeah? Okay. We can vegetate about anything, and it seems like we have a passion to, but this, for me, I'm starting to think about, the abstractions, and I doodle when I talk to people on the phone. So I'm thinking about how this can inform, my art can inform my work, and Terry's phone number is somewhere in the corner, but if you call me and I'm talking to you, it's not that I'm not paying attention, it's that I'm actually focusing on what you're saying, and I'm thinking about, well, let's take those forms and abstract them and start to apply them. And this is actually turned, when we put it into the IBM, it turned the world on its head. But that's the garage on this interesting project, and it's the test for a living wall system, an art system that's in Three Rivers, which is at the base of the Sequoias, 8-inch rainfall, lots of 120-degree days, and that's the kind of growth we've had with 15 different species of plants. It's soil-based, and I want to go back here because I've lost one of the images, and I wanted to say that this is it's an estate home, but it's the laundry for all the different homes, and so we're taking all the laundry, gray water, and integrating that with the stormwater, and zero potable water is used in a fairly desert, arid climate for this living wall. It is soil-based, and it's based on the use of reclaimed water, and that was just our first little mock-up. And this idea of art, we can take this abstraction and think about its application to landscape and design. I think that's where the spirit of our work really comes from, is this integration of art and ecology, engineering. And this piece I've just been commissioned to do really incorporates metal sculpture and color. It's on a gallery, and then thinking about, well, why not just frame the pictures and start putting living walls in pictures? And the last scheme looks something like this, focusing on ecology and different species. So that's kind of the story of living architecture, but I had just one final little project, this 6.5-acre convention center in San Diego. I'm just really pleased with. They had a problem with 400 gallons a minute of brackish salt water underneath the building that they're discharging into the bay. So you can imagine that. Man, they're writing checks. Every gallon of water going into the bay for their discharge permit, and then all that energy. And they're planning a new expansion similar to what happened here, and I said, well, why don't we use every drop of that water, commingle it with stormwater, and we're going to create saltwater marshes up on top of this roof with mangroves and all the saltwater marsh ecologies that were once found on the site. So these are wetland cells that are going to process contaminated brackish saltwater, floating those programmatic conveyances, either walkways or boardwalks, and then it ends up here in a 3,000 person amphitheater. So that's kind of where we are. I feel like we're just took off. It's an exciting time for us all. We've got a great history of working together throughout the world, great networks of people, good organization, terrific products. Policy is moving forward, and I couldn't be more optimistic. Thank you very much for inviting me to come and share with you some of my work, and good luck in the future. If there's any that need to be asked.
Out there? Does anyone have a question for Paul? No? Yeah.
I like the coconut boxes that you had on that rooftop. Are those available for the general public?
I'll tell you what, they are available, and Trimco is a large roofing manufacturing company, and they just bought that patent, and I'm working with them to do the BioCrate 2, which is made out of hemp. And so hang on, this coconut is a great idea, and it supports some of the forest farmers in the world. It's organic coconut, but hang on tight because we're going to introduce some organic, local materials. And but you can call me or Trimco, and we can give you information about it.
And the last and final question for me is, at the very beginning of this lecture, you mentioned a Kaiser building and a Union Station that failed. Could you very briefly say why it failed and how we as homeowners or whoever doing Ecoroof can prevent the same mistake?
Both of those projects, you've heard of Ted Osmondson, a great founder of Green Roof Design. He wrote the book in the 70s, and he was just honored for Lifetime Achievement Award. Wonderful designer, but at the time we didn't have the stable and reliable waterproofing, and coal tar was used quite often, which with blister and crack, and what I call the kiss of death occurred, and that's when, and I still won't do this, is when the architects and I love to argue about this topic. And then the waterproofing is put over a slab, and then for security reasons, a topping slab is laid over, and additional waterproofing. So if any of that failed below, they had to just chisel it all out and start over. So both of those projects failed from waterproofing, but that again goes back into the medieval times of green roofs in North
Wasn't that
America.
the 60s and the...
That's right.
The 60s,
early and late 60s.
Very large. They were very large.
That's right. And so that topping slab to me, and now with these, I mean, you can count them. There's 5 or 6 great manufacturers, good warranties, good systems, good service delivery we have now, so that, and leak detection systems. So with that, having said that, I have a great deal of confidence to even do things like what I'm doing, building constructed wetlands and, you know, large water bodies and saltwater emerged plant communities on rooftops. Thanks again, everybody. Have a great afternoon.
Yeah, thanks for hanging out, everyone, and please feel free to go back into the hall and see those vendors. They're probably looking forward to seeing you. Hi, how are you? Good. We don't.